Okay, we are going to continue to do proofs of arguments that have statements with quantifiers. So far, we have introduced 3 rules that apply when we have or want quantified statements. When you have a universally quantified statement, the universal elimination rule or universal instantiation applies. When you have an existentially quantified statement, the existential elimination rule or existential instantiation rule applies. And if you want an existentially quantified statement, you want to show one, the existential introduction rule or existential generalization rule applies. What we don't have yet is a universal introduction rule, a rule that allows us to show or get a universally quantified statement when we want a universally quantified statement. So that's what we're going to introduce now. But before we do, let's stop and review the 3 rules that we already have, because we will continue to use these rules in concert with the new rule. So here is a proof that requires all 3 rules, and it's not a terribly difficult proof. I recommend that you pause the video and work it with pen and paper or use the proof checker on your own before doing it together. Assuming you've already done that, let's get started. And as usual, I recommend starting by noticing the main operators and/or quantifiers. In this case, they're all quantifiers. So we have a universally quantified statement, we have an existentially quantified statement, and we want an existentially quantified statement. When you want an existentially quantified statement, you should be thinking of the EI rule, the rule that allows you to introduce an existential quantifier. When you already have a universally quantified statement, you should be thinking of this rule because it allows you to get a statement that doesn't have one, should you want one. And likewise, we should be thinking of the existential elimination rule. And I always star this one because I know, using at least the book method for using this rule, that it has to be applied first because there's a constraint on what you can choose for your indefinite name. You cannot choose a name that is already in play. So if you start with the universal elimination rule and say, from line 1, I get, let's just choose A as a name. Well, now I cannot on line 2 get this, right? Because you are not allowed to choose a name that's already in play. And yes, there is a convention of choosing a name from the middle of the alphabet, but the main issue, like I could have chosen P here, right, instead of A, and I still can't put P here because you can't choose a name that's already in play. And if you can't choose a name that's already in play, you aren't going to be able to use the fact that this looks an awful lot like modus tollens, but if this isn't P, if you have to use a new name like Q, you won't be able to use modus tollens. So always put a little star here if you're using the book method anyway, that this is a rule to apply first. Okay, so let's get started. Erase all of our hints. On line 3, I'm going to start by choosing P as an indefinite name. I'm not naming some specific known individual. Line 2 says something is a non-Q or something is not a Q. I don't know which thing, but let's let P refer to the at least one thing that's a non-Q, whatever thing it is. It's an indefinite name. And I'll justify that like this. And now I can use my universal elimination rule. And I'm definitely allowed to use P because I know universal statements apply to everything, and there isn't a reason for constraining this. So 1AE. And now I can use modus tollens This looks just like it did in propositional logic, or at the very least, the wording of the rule. The schematic would look differently, but the rule that we have written in English is the same. We have a conditional statement. Yes, we have the negation of the consequent, and we just put on a new line the negation of the antecedent. So followed it to the T. Nothing has changed. Okay, then the next step, now that we have line 5, we can introduce the existential quantifier. Line 5, E introduction. And I'm using the shorthand from the proof checker because it is shorter, and it's also, I think, a little easier. Are you eliminating things or introducing things? With modus ponens, we use arrow elimination. Modus tollens, you're also eliminating an arrow, but you can't use the same name for 2 different rules, which is so just still using MT, I guess. What to call things is a matter of convention, but some conventions are easier to remember than others, and some are quicker to write. So I'm going to do the quicker to write ones. Also, they're kind of easier to remember. Okay. This is the way the proof has you do, or this is the way the book has you do this proof. But as we saw, the proof checker sets it up differently. Instead of just let's all know this is an indefinite name and what that means and constrain it so you can't use something that's already been used in the proof and blah, 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 it's going to put different constraints in place so you can't prove things like we did last time where we proved your teacher is the Pope. Here's how the proof checker does it, just as a reminder. Instead of just putting what we did on line 3, instead, we're going to start by making an assumption, and that assumption will be exactly the same thing. And in the proof checker, we never have to justify our assumptions, not for conditional proofs, not for indirect proofs, and not for doing existential elimination. Okay, so line 3, we'll start by making an assumption. Everything else goes the same until the end. So I'm going to use universal elimination, just like I did 1AE. And then I'm going to do modus tollens, and I'll get exactly the same thing from the same lines. And then I'm going to do the existential introduction step. Everything has been identical. The only difference is I'm doing it in a subproof. And then when I hit the thing that I want, that no longer has this in it, see there's no P left when I get to the last line, then I am allowed to close up the subproof, and on the next line, I'll write whatever the last line of the subproof was, symbol for symbol. And I justify it by citing line 2, the one that had the existential quantifier, and then also everything in my little subproof here that says, let P be the name of such an object. Here's what follows, and I ended with something that did not refer to P in it at all. They're just X's. And I will call this EE. Okay, so that's how they look side by side. If you haven't already, I recommend doing this. I know it's like, oh, that's a new thing and it looks harder, but if you haven't tried doing it in a proof checker, it really isn't that much more difficult. And as we'll see shortly, the book and the proof checker do universal introduction slightly differently, and this time the proof checker is easier, and you have a choice of which one you'd like to use. But the proof checker is nice to use because when you make mistakes, it'll tell you that, and it'll tell you exactly which line your mistakes are on, and it'll tell you when your proof is correct. And because there is more than one way to do a proof, your proof may be correct and look very different from sample answers. So having a proof checker that can tell you that any correct proof is correct is really a useful thing to have for the next week or so. So don't be afraid of the proof checker.